Right, so this is going to cover question 6 on the fall 2016 final. And the question asks us to show the left-leaning red-black tree that corresponds to the 2-3 tree on the left. And it tells us to indicate red nodes with an asterisk. And so in the case of 2-3 trees, right, we know that there are two types of nodes. We have a 2 node, which contains 2 children, and a single value within the node. We also have 3 nodes, which have 3 children and 2 values contained within the same node. And so when converting from a 2-3 tree to an LLRB, the 2 nodes are pretty easy, right? So 2 nodes look basically the same in a 2-3 tree and a LLRB. On the other hand, converting 3 nodes is a little bit more difficult, but we can use this conversion right here. Basically, every time you see a 3 node, which contains values, let's say A and B, you can convert it to an LLRB by creating a black node with value B that has a left-leaning red child containing value A. And so in this case, we also should consider the children, but the children can be converted as such. Or if we have children's 1, 2, and 3, then 1, 2, and 3 should go in these places right here. And so now let's actually do the conversion on the 2-3 tree given. I usually start at the root, and so this root is going to be a 3 node containing values 10 and 40. And so 10 and 40 when converted to an LLRB would look something like this, where we have 40 as a black node, and then a left-leaning red child, which contains 10. The 3 children will look like such. And so let's start with the first child, right? The first child will be right here, and it's going to be a 3 node that contains 5 and 8. And so once again, applying our conversion, this would look something like this, where 8 is a black node and 5 is a left-leaning red child. And so what are the children of this 5, 8, or this 5, 8, 3 node, right? In this case, we have 3 children here, 3, 6, and 9. And so where do each of these go? They would go in these 3 spots right here. And so if we look at each of these children, none of them are 3 nodes. And so converting them should be pretty easy, right? We place 3 in the child 1 position, 6 in the child 2 position, and a 9 in the child 3 position. And so with that, we've figured out how to convert this first child subtree. Moving on to the second child subtree, right? The child itself is going to be a 15, and 15 has 2 children. On the left, we have 14 right here. On the right, we have a 3 node containing 20 and 30. And so in this case, we can place 14 since converting a 2 node is pretty easy, and 20 and 30, we can apply our conversion, right? 30 would be a black node with a left-leaning red child of 20. And so finally, let's move on to the third child of the 10, 40, 3 node. So in this case, it would have 90 as a child, and 90 has 2 children. One of them is 80, and the other is 95. And just like that, we've converted our 2-3 tree to an LLRB. Question B tells us we want to basically do the opposite. Now, given a red-black tree, we want to convert it to a 2-4 tree. And so the way that we convert red-black trees to 2-4 trees is that we can think of it as absorbing any red children into the parent. So what do I mean by that? Let's say we're looking at this 10 node here. Okay. And so 10 has a red child, which is 20. And so in the 2-4 tree, 10 and 20 should be in the same node. Similarly, if we have this 5 node here, which is black, with 2 red children, then both of the red children should be in the same node in our 2-4 tree. And then for the 16, 12 will be contained in the same node as 16, and we'll also have another node containing 25. And so let's actually draw out our 2-4 tree now. So at the root, we have a 10, but remember that the 20 is also contained in the same node. Then we'll have 3 children, right? The left child is going to contain 1, 5, and 8, everything in purple. The middle child is going to contain 16, and 12. And then the rightmost child is going to contain 25. And just like that, we've converted our red-black tree to a 2-4 tree. And just to show the correspondence, let's highlight all the colors. Okay, so we have 12 and 16 here, 1, 5, 8 here, 10, 20 here, and lastly, 25 here. And so those are the conversions from a red-black tree to a 2-4 tree.